We are Team 19, and we have the Sunniberg Bridge, which is in Klosters, Switzerland. It's a little history behind the bridge. Construction started in the spring of 1996 and was completed in the fall of 1998. This bridge was built to serve as a connection of 3 bypass roads from surrounding towns in Switzerland. After it was completed, it served as a construction access to the tunnels and did actually not open up to the public until 2005. 2001, it won the award for Outstanding Structure. This bridge spanned a length of a total of 526 meters. It crossed the Landquart River in Switzerland. This bridge is considered an extra dose bridge, which combined both the elements of a cable-stayed bridge and a pre-stressed box girder. The bridge has 2 lanes, one in each direction. Total cost of the bridge was $16.6 million, and construction time actually took less than they were expecting. You can see where we outlined here those who participated in the project. Most importantly, the designer, Dr. Christian Menn, who we will touch on later, was a very innovative structural engineer. Now we're going to get into the rehabilitation and maintenance of the bridge upon completion. Around 2005, when the bridge was expected to open to the public, flooding was a big problem in the Alpine region. It ended up uncovering the foundation and pile cap of the 3rd pier of the bridge, yet no settlements were observed, so the bridge did open as planned. In the bridge's early years, water was beginning to freeze in the drainage pipes, so a heating system was installed. As far as the maintenance of the bridge and the inspection of the tendons is done with a lifting basket, and since the bridge is only 2 lanes, the bridge must be shut down during that time. The bridge sits around 1,050 meters above sea level, which increases the chances of low temperatures and high precipitation. The stay cables are able to be replaced on the bridge, and there was also corrosion-resistant reinforcing steel set in the bridge. One of Christian Menn's early bridges that he designed was the Ganter Bridge in Switzerland. This was completed in 1980. The bridge looks similar to the Sunniberg Bridge, but the cables themselves are actually encased in concrete. Next, we'll take a look at the lasting impact that Christian Menn had. Here you see a quote in his early years, which served as his inspiration for this type of bridge. Another impact he had was when, around this time, concrete was largely known as a bulky material, and he found a way to make it look nice, and it was in a sensitive landscape. He also put an emphasis on extra cost, increased about 5 to 7% to increase the aesthetic in the bridge. And lastly, his research focused on minimum amount of reinforcement, crack control, and corrosion control to increase the durability. Here you see a bridge completed in 2010 in China. This is also an extra dose bridge, which looks very similar to the Sunniberg Bridge. It spans 756 meters.
The curved plane of the bridge allowed the concrete deck to be cast as a monolithic slab without expansion joints at the abutments or bearings at the piers. As a result, the piers are restrained both laterally and longitudinally by the deck, rather than being cantilevered from their foundations, thus enabling them to be slender and visually unobtrusive. The piers or pylons are constructed from two legs connected at several points to form a vertical Vierendeel truss. In the transverse direction, the piers vary in width with height, from 8.8 meters at the base to 13.3 meters at the roadway. Above the pylons flare to 17.25 meters. This creates a cupped form which cradles the road. The Sunniberg Bridge is a harp arrangement cable-stayed bridge with three main spans. The longest measures 140 meters with two side spans. The reinforced concrete deck is 526 meters long and follows a tight curve of radius 503 meters at an inclination of 3.2%. The deck is 2.37 meters wide in total, 9 meters wide to curb, and it carries two lanes. The piers pylons are also constructed from reinforced concrete, the tallest of which rises a total of 75 meters above the valley floor, 62 meters up to the roadway, and 15 meters above it. A simplified version of the bridge was created in the program SAP 2000 to allow one to run a structural analysis on it under common loads. This was accomplished using the frame section command that allowed for the bridge piers and bridge deck to be drawn as simple linear tendons. Cables were then drawn from the piers to the deck. A live vehicle load was applied to the surface of the bridge deck via a path created parallel along it. Pictured top to bottom respectively are the shear force, deformed shape, and bending moment diagrams after the aforementioned load was applied. A more detailed summary is available in the supplemental report provided. After initially trying to draw the curved bridge in SAP 2000, it was apparent that the model needed to be simplified due to lack of knowledge of the program's functions. Additionally, the pylons were made into a single solid for simplicity. Initial issues arose with the addition of cables, but with research were eventually overcome. The model was handcrafted due to limitations in 3D printing. The four piers were carefully measured and cut to the exact dimensions of the Sunniberg Bridge. The bridge deck was then tightly secured on top to finish the model. Due to the pure breadth of the bridge, it was not able to be 3D printed as a result of the bridge deck being too thin. In terms of the finished model, cables were not able to be attached due to time restraints and sanity of the building.
After facing the challenges discussed with this model, we learned that keeping the model simpler makes it easier to create. It's also apparent that Christian Men serves as an innovative inspiration to all structural engineers. In conclusion, we can learn a lot from structural engineers who seek to be different and think outside the box.